Okay, welcome everyone. I am the chair of this section. My name is Hong Chi Kang. I'm coming from Zhongzhen University, from Jiayi. We have 4 teams in this stage. So I would like to have each team leader introduce your team members first. Your team. Okay.
We are all friends, and I'm the master. I'm Tommy, and he is right.
We're Me Too from Wego Senior High School, and I'm Yu Dongyue. This is Yao Zeyu. This is Wang Lian. This is Lin Muyu. This is Wang Xuanqi.
Hello everyone, we are students later. I'm going to this Wang Yaojue, Chen Yuan, Chen Wei Zhen.
Okay, thank you. And I would like to have the jury introduce yourself, please.
之前的开发双方的关系。
I'm Heidi from National Central University.
Okay, now we'll start for our first stage. And so the opponent challenge the reporter. You have 1 minute.
We would like to cover the state.
We reject. We reject.
Reject. Okay, the reporter reject.
We would like to cover number 5.
Number 5.
We reject.
Okay, the reporter reject. So the opponent proposes.
Now number 14 and number 10 is available.
Okay, for the reporter, only number 14 and number 10 is available.
Okay, we would like to join cover 14.
We reject.
Okay, the reporter rejects. So the opponent challenge again. In the meantime, what's the total number of rejection from the reporter now?
4.
4. Okay, so now what more to go? There's only 10. Okay, for clarity, the opponent can challenge number 6, 7, 8, and 13. Number 6, 7, 8, and 13. That's on the board. And the 10. Sorry. So on the board, these are the problems. Sorry, there was some.
We would like to number 6, problem number 7.
So problem number 7.
We accept.
Okay. So the reporter has 5 minutes to prepare for the presentation. And please, for each team, the reporter, opponent, and reviewer write your name on the board. Okay.
Opponent.
Opponent, please write your name on the board. Okay, reporter takes the floor.
Hello everyone. We are team office and today I'm going to talk about giant sounding plate. This is our outline. And this is our topic. When this small plate and you will read it and you will have a loud sound. And we are going to talk about these sounds. And so our main focus is the cause of the sound, is the why it has sounds and how the wave look like. And this is our theory. We thought that it was a transverse wave. So we searched on the Wikipedia. So we found that the B of the transverse wave is the square root of G by rho. The G is the transverse constant. And when the wave is played, and you will make a stationary wave, and so that we can find out that the F is this equation. So our theory is just like F is equal to A times N, and we're going to find that A is it is the same as the theory. So we choose to play one and play two, and we get the number of these things, and we got the A in the theory. And it is our experimental method. When we make the plate and make it have sounds, and we get the sounds and add it to the Fourier analysis, and it will go to the field, and we find a peak, and we make it into a plate. And this is our data. This is our two plates. It is plate 2 and plate 1. So we can count that the plate 2 is more the frequency of plate 2 is more higher, and the frequency of plate 2 is more lower. And we also can count that the plate 1, the A of the plate 1 is bigger, and the A of plate 2 is smaller. And this is our data for the A of the theory and the A of the experiment. And we found that is nearly the same. So we can say that our theory is nearly likely correct. And yes. So this is our conclusion. When the plane is big, and you will make the transverse wave, and Z is this, and it will be and we can, after some calculation, we can know that the F is this thing, and we can just turn into F equal to A times N. And we can find that the sound of the two plates is good, and the frequency of the plate 2 is higher, and the wave speed of plate 1 is faster. But we also got some problem. It's like the constant of G is not that easy to know. So the G constant is have a little bit wrong. So our theories of the A is have a little error. Thank you for listening.
howling, right?
Yes.
You record it, and which part of the you are howling a really long time, right?
Yes.
And you recall a howling like when you when this document like really long time.
Oh, I read the whole and the background would I have kind of the background.
Okay. And you say talk about the pig. Can you explain what is the pig?
The peak is like this.
Can you explain what is why here? What does that mean in text?
What is it means the sound I hear is more real. It's
sound is more bigger, right?
It's the place frequency
Okay.
is here, and so it will be bigger.
Okay, so I think you need to explain it more clear while you are doing your presentation. Okay, so the next question I want to ask you is that which one factor in your experiment will affect the, like, you talk about the state of the wave, right? You also talk about then can you explain the connection with it? Like which factor will affect the state? Maybe you can say it. Just say it.
The speed is
It's
G by G.
But G is a constant.
No, the G is
Okay, fine. We can discuss in the discussion time. Thank you.
Okay, the opponent have 3 minutes to prepare your presentation. Okay, the opponent take the floor.
Okay, so hello everyone, my name is Ponte from English. Now I'm going to propose a problem number statement for giant stone plate. So in problem statement, with a large sink and flexible plates, for example like plastic, metal, or plastic loud and unusual howling sound. Expands and expands to gain this phenomenon. And in my discussion time, I will mainly focus on why can this phenomenon happen and how do the relevance parameter affect the results. So, in a reporter's presentation, we talk about surgical model like F equals to A times and transverse wave. And I didn't talk about his pros because he doesn't show too much like theoretical model or experiments in this, so I can't talk about his pros. His cons that I have suggestion want to talk to like he doesn't explain the theory clearly and doesn't have enough to explain the phenomena and doesn't do any connection with it, so I can know that anything about the connect with the experiments. And experiments and setup is frequency of the play. But here, it doesn't show us the experiment setup so we can know it clearly. So I will talk about it in discussion time, maybe we can figure it out together. So his concept, it didn't consider enough control variable and depth of parameter, and didn't have enough experiment to explain this phenomenon, and didn't explain the experiment process clearly. In the data analysis, we talk about web split and different frequency in his conclusion, you can see that. But sadly that he didn't talk about the connection with his theoretical model, so we don't know that. And I will discuss it later. And his cons here, it doesn't have comparison between the theoretical and experimental value. And we can clearly see it's only through one parameter which we can know that any conclusion of this. And his lack of quantitative data and lack of error analysis. And he also doesn't have error bar, and we can know that what kind of factor will may affect the results. So in my presentation, I will mainly in discussion time, I will talk about the theoretical model and the connection with the phenomenon. And in the experiment setup, I will talk about the experiment process and accuracy observation, which will make his presentation and the experiments more clearly. And I will talk about the data analysis with the accuracies of the data and the connection with the theory. So thank you for your attention. And now I want to discuss with the reporters. So I have some question I want to ask you then. Can you turn to your conclusion? Maybe we can start from the conclusion. So you say that the frequency of play 2 is higher and the wave speed of the play 1 is faster. Does that have any connection with your theoretical model? Maybe you can clarify here.
I see this in.
Maybe you can draw in the back, or then you don't need to turn your
I
PowerPoint.
see
It's okay.
I see here because this guy is so
And tell me first, what is the y-axis here?
this x is frequency.
Frequency. Okay.
This is just a number. This is the first peak, second peak.
Okay, the peak, just like you say. Okay. And then, is there anything you do this try and can prove anything?
I just do this to prove that the theory that I think is right. Because
So you just do an experiment and prove your theory is right. But in the problem statement, they want you to explain why drawing plates sounding plates can make the noise.
yes, so our theory is told that. So I'm
And maybe turn to your theory.
I say the three is why this is just not why it will make the sound. So
Why? Just okay. Explain this formula for me. Why? Because you can just because of a formula and say you can make a sound. Does not make sense. You have okay.
because now you have a tape and you just wave it and you'll become like it will become many small bits and will just like this kind of wave and it will make sound so we can become
You can make sound, but you still didn't talk about it. Because
simple noise.
okay. Maybe you can say this to me. Okay. Then I have another question I want to ask you. If you can. So that's I'm just wondering that because you only do one parameter here, do you do any knowledge investigation in this? are you doing a different material of the plates or like?
I do two different plates. Just because I can't found the metal plate, so I just take two.
Okay, so they are both the metal material,
They are plastic.
plastic, both are plastic.
Yes.
And what was the difference between these two? Since you said they are both plastic.
They are two plastic, but their basic data has a little bit different.
And how did you get your basic? It's like,
The rule is the math by the math. This is density, so just math by the volume, and this is two. And the G we call it just volume.
oh, okay.
I just do this. I take the thing, and I take here,
What is this?
just let it at here. Just don't move.
Don't move, and let it stay here.
Yes.
Okay.
And I put a mask on it, and you'll become
Oh, it will-
this,
it will be bad.
and we just get this, and we can count G.
Oh, got it. Is it just like elastic?
It's like a thing this, and when it becomes this, and
Oh, then you can get it. Oh, but you didn't talk about it in your presentation, so maybe you can, when you're doing the presentation, maybe you can say it because you won't notice it how you do mine is different. Okay, and another one that since you said that you turn to one, like the one that have a pig. Yes. How do you do to make like you said the background noise? How do you remove it?
I use the tool to do it, and the tool have
And how do the tour know that it's not a sound that made
Because-
from the drying sounding plates?
because I have just our sound I have get.
Okay.
It is not the place I didn't in the plate, and I didn't. So I can just use the place that I didn't put the plate to cut off this.
And since you drew that picture, you remind me of something that you place a object on the center of this giant sounding plate, right?
Yes.
But what if when you do an experiment and you change the force and this will it change the noise make from?
No, I put it here. I just want to get the G. And when we are
Okay, then
doing
you
the
tell me about your experiment setup.
our experience setup is very simple. Just I get a hand and shake,
And you use your hand and shake it.
and I get a phone.
And you might have a better way since you do the same experiment. So I think you should like put it not using your hand. Maybe you another like robots and you can
But
explain it.
But the sound won't be different for but because
So the sound won't be different, the frequency or anything will be different.
but I got a frequency long. Just like maybe this sound will get like 20 seconds, and there is somewhere is no just like background sound and the place sound.
Also, you
And I will get here to do the prayer, and I will cut here to do the paper.
okay, I got it. So the one is the background noise and the noise made by the like the sound effects is because of the amplitude is different. So you can use the amplitude to tell this amplitude is small and this amplitude is big. So you can say, oh, this is the noise you want to get.
Yes.
Oh, to like the giant sounds like, do you have a particular page that you have a thoughts? You have arrow bar here.
Yeah.
You didn't do it, and you just only do it one time, or you do many times. Give me an
Because
arrow.
it's very long, it's a long time, so I didn't.
But I think you should clear it because, okay, so how many times that you use the same giant sound effect? You use it for like a lot of times.
Yes.
But you do know that like you use a plastic, it might will be have like a module of the elasticity. Because when you keep doing this, it will make bending and the shape is not the original ones, right? Yeah, so it will affect it. So I think we should improve this, and maybe you can buy more sounding plate and do an experiment. It will make your experiment more accurate. Okay. So I have a question I want to ask you is that since I asked you about like, do you consider what if a giant sounding plate, the size of it is different? Do you think it will affect this?
Yes. The size will change the density, and this L is
Why
the
size will change the density? Because the same material has the same density, right?
maybe will change.
Maybe.
Did
Did you do an experiment?
Because I didn't find.
Good point.
Because this didn't help. And the theory that I say the L is because I'm holding this shape, so the L is this. So if I hold this shape, it is this. So it is the L is to go
Okay.
at here.
And
So
what,
the L will be changed.
now I get this. And what about the thickness? Do you think it will affect your experiment? Because you didn't do it, and then maybe you have a knowledge background of this, and I want to ask you because I'm curious about this. Will the thickness of this will affect the result? Thickness. Thickness is, and this is a giant sounding place, right? This is for the thickness of this. Like how? Okay, you get this. This is called. Yes, this would be the giant sounding place, and this part would be the thickness. And do you think that the thickness will affect this? Use your knowledge background.
Our theory says it was because it just caused by the L, but maybe it will because the plate is maybe not straight, it may be curved.
Okay. Thank you. And that's all my discussion.
Okay, the opponent summarized the discussion.
Okay, so I'm going to summarize my discussion. So in the theoretical model that we talked, I don't think Siri just mentioned in the reporter's presentation of what a problem statement will want us to explain. And we discussed about his formula, and I want to find a connection with his formula. And if after our discussion we can know more about that, probably the thickness and like how mass of it will probably affect the results. And in the experiment setup, I understand how the reporter set it out, and the method he should depend, and that's on the thickness. And I found out that he using the hand, but using the hand might will have an error in this, so I think he should improve it, and I think he already understands it and will improve it in the future. And we discussed about how the recorder prevents the background sound, but he didn't show a specific answer, and we talked about error and error analysis in his data charts. And I think after our discussion, we can know more about this.
Okay, so the reviewer asked questions.
I'm the reviewer for me too, and now I'm going to ask the report. So can you provide any videos of the howling? So what is the howling sound? Do you have any video about that?
Is this can
Oh, thank
be a
you.
cell? I
And,
have it.
and you said that you give a lot of suggestions about the parameters.
Yes.
Then what do you think is the best parameters that can improve his experience? So which parameters is the most important?
I think it's a mass of it. Why? Because he talked about, in his formula, he talked about the density of it. So the mass of it and the volume of it might affect it.
Okay, then the report, you said that the shared modulus is incorrect, right? Can you elaborate more? Why do you think that is not a great way to use?
What is that?
Can you turn to the last page? Oh, this one. Why do you think that is inaccurate?
Because,
It's okay.
uh,
What do you think is a better way for the reporter to quantify his experiment?
I think he can use, just like you show us charts, maybe he can use it and to make us to see the charts, because there will be a frequency here. So you can use the frequency and to prove that his theory.
What do you mean? I mean, how can you quantify his experiment? Because we know that his experiment is not quantified, right?
Yes.
So what do you think is a better way, or you can suggest how is a better way to quantify?
Maybe have a frequency, because frequency will have a data, right? And frequency and the speed of the wavelength, then we can have quantify this.
And the report. What do you think? Why is the sound is how? Why is it a howling sound? So where is the source of the sound? And you two, the question. Where do you think the howling sound comes from? Why is it the howling sound?
Okay. I think it's just like a picture he writes. Yes. Because of the shape of the sounding plate is changing, so it might it will make when the places change and it will affect it will have a sound of it because yes, that's I think.
Okay.
when sound is constant, just to make sure that you will have that, and just like you have that wave, and when you see it sounds like howling, just.
Time's up.
Okay, thank you.
Okay, the reviewer has 2 minutes to prepare. Okay, reviewers take the floor.
Honorable judges and working debaters, this is the reviewer from Team E2, and I'm going to review problem 7, giant sanding plate. So this is a problem statement. When a large and thin flexible plate, and there's different kinds of plate, right? And it is bent, it can produce a loud and unusual howling sound. So we need to investigate this phenomenon. Their focus is to explain the phenomenon and investigate the wave. And the report, they say that it generates a howling sound by the bending of plates, and there's theory they just include the transfer wave. And the experiment they did is they bent the plate and the sound is created, and then they recorded and analyzed it. And they found different kinds of frequency for the plate. And then they said that the shear modulus measurement is inaccurate. Yes. So this is the pros and cons of the report. They have detailed explanations of how they get the formula and combination between their theory and experiment results. For the cons, their source is kind of not credible, and they have unclear graph. There's no units, no x or y axis explanations, and they take too less parameters into consideration. So we cannot really know what they're trying to do in this experiment. And for the pros of the opponents, they released a report to clarify their experiment, and which these to tell us more parameters that the reporters should consider, and they give practical suggestions on how to investigate other phenomena. But they kind of lack some constructive opinions on the topic. So these are some questions of the opponents asked. So what is the connection between the experiments and theory, and how did the graph explain your experiments? And then the report says that he tells us what is the y-axis and how he proved it. And we think that the graph isn't answering the question at all, and the opponent gives a great suggestion is please clarify your x-axis and y-axis. And then the second one is, why did you choose to use this formula? And the report did not quite answer the questions, and we think that that is because they have lack of research in this topic. And then the opponents asked, what are the parameters for your experiment? And did you consider other parameters? And the reporter says that they only use the plastic plates. And I think that they should consider more parameters so they can prove this theory and also investigate more phenomena. And I think the opponent should also give more advice in this part. And then the opponent asks, how did you make the background noise to become negligible? And then the report says that they use online tools to remove the background noise. So that is not really reliable. And then the opponent asked that, did you notice that it is inaccurate to use your own hands to bend the plate in the experiment? And the reporter says yes. And I think for this part, opponent can give some suggestions of how do you think is a better way to do this experiment. And then I think the reporter should improve in this part. And then the opponent asks, do you think the size of the plate will affect the results? And the reporter says yes. It will change the density, and we think that he failed to answer the question provided by the opponents. And then I think that the missing point is that this the research that reported did need more research on these experiments. Thank you.
Okay, the concluding remark from the report, you have 2 minutes.
It is our conclusion remark. First, my report should go deep and more carefully so that you guys can know what I'm talking about. And things I want to talk is about the tool that I used to remove the background. I didn't use online tool. It's not an online tool. I use the OLA app, or use the OLA CD to remove the background. So, and just like I have said, I didn't use I used the tool, but it's very correct. It's not wrong because I just choose the background and cut off the background. So and it's not the online tool. So and I think I have to make more experiments like the metal plate. So next time I should pay some money to buy the metal plate. And just like I said, we should go deeper in this project. Thank you for listening. This is my conclusion remark.
Okay, so time for questions from juries. So any questions from the jury?
Yeah, I have a question for three of you. So, since all of you all mentioned about the handshaking problem, so how do you improve that part? Yes, so
I think you can make a robot and shape it. I think it will be more accurate because the robot is made by the computer and we can use a computer and control it more accurate.
So, I wanted to say that I have seen to use the robot to do it, but the robots cannot make the sound perfect because the robot just can use it and this won't cut sound. You have to, your hand can more perfectly to yes, to make the sounds, and it will be louder.
I think that because robot is not really accessible for high school students, so a better way is to use a stabilizer because it can stabilize and quantify the howling. So that is what we think.
Other questions?
Okay, I have a question for all of you. If we use the same experiment you just mentioned, and if we put a whole set of the instrument into a vacuum system, can you think about how can you make a sound? If you put the instrument into a vacuum, vacuum,
Oh,
you think?
There will be no sound.
yeah, I think it's with sound as noise.
Yeah. So that's why I suggest, because this problem we are talking about how to make a sound, discuss how to make a sound. I think medium is one of our key points. Because as I just suggested, if you put all the same instrument into a vacuum system, you will know it doesn't make a sound. So, thank you.
Please report show your data about the peak frequency and the number. Okay, and we can see in principle the peak frequency should be proportional to the number, right? However, in the data you can see is the data do not pass the original data 00. Okay, can both of you shortly explain why the data do not pass through 0 and exact matter? Okay, please.
Yes, this didn't pass the 0. It's more because when I feed this, I give it the y equal to ax plus b. So this have b is here, so it might be more correct. So if I do it again, I will just feed the y is equal to a times x.
Okay, and
No, I'm not sure we didn't really understand that how does he make the chart. So I maybe just have some problem when he's doing the chart and he will have the frequency is not reaching 0. I'm not sure about it.
Me too, because I think the experiment is not really quantified and they're not elaborate, and it is wrong on the x-axis. So we think that is why we cannot see the phenomenon.
okay. What's about x-axis?
It is wrong.
Okay, so if it's wrong, how to correct this result? How to modify this result? Okay, maybe. Okay, fine.
Okay. Quick questions. For howling sound, is all frequencies important or only some in frequencies important? For howling sound, so all frequencies important or only some frequencies important in this experiment?
I think both were balanced.
Okay.
I think it's a sound.
Okay.
I think we should more focus because it's the police. So I think if we want to see the Holy, we should look at this picture to find what is the Holy. But if you want to know why cause the sounds, is more like us to.
Okay, time's up. So please, Julie, mark your score. Okay, so the score for the reporter. Okay, 4. Please show this way for the recording. Okay, 4, 4, 6, 5, 5. Okay, and score for the opponent. Okay. 9, 9, 8, 8, 8. And score for the reviewer. 6, 7, 9, 8, 7. Okay, so comments from the jury? Any comments for the three teams?